Hello, everyone. Can you hear me? Can you hear me?
Yes.
Okay, great. All right, so hello. Welcome to 372, ITS 372 online edition. Still learning how to use this, so I apologize. Let's see. I think I've admitted some people in here. Let's see. Yes, I get some of you saying that you can hear me. All right, great. So hopefully you had an opportunity to look at the videos from last week. This video is being recorded, so just be aware of that. And I don't know what the quality of this will be, but I will post this video basically, if it looks okay, again on YouTube, and then I'll link it on the website, and that way you can take a look at the notes again if you have any questions or anything like that. So I'm not sure how, obviously I'm going to do a lecture today. Hopefully that'll work. But before I start with the lecture, I just want to know if there are any, well, I want to make sure first of all that everyone can hear me, and then if you have any questions, please so please ask right now if you have a question. Or just say something so I know you can hear me. It's kind of difficult. I know Alicia said that she could hear me.
We can hear you.
You can hear me, Josh?
Yes.
Okay. Okay, Anthony says I can hear you fine. All right, so it seems like everyone, so I'm getting some messages here. I can hear you. Okay, great. So I'm going to assume if, you know, that everything is working. Okay, so as you know, we're using Zoom. Now, I believe this, some people have told me that this cuts out at 40 minutes. I extended it, I think, so it should be able to record the entire class. And then, yeah, so that should be it. So I guess there are no questions. All right, so I don't think, I should say that you're not required to attend these necessarily. I will post the videos online as well. At least that's my intention. But if you do have questions, you can use this or email me, or I will have, oh, I should say I will have office hours. I think I wrote it down on the Blackboard, and that would be Tuesdays, I believe I said from 2 to 5 or something like that. Or actually, I have a class, I think it's Thursday, but just check on Blackboard. The information should be there. And always, please check your email. That will be the main way that I will contact you, is I will send an email, I guess. We're gonna do these sessions, and of course you can ask questions here. I remind you, so before we get started with the lecture for today, I remind you that I believe I said we have an exam, the second exam next Monday, correct? Is that correct? You guys are aware of that? You can just say somebody just type it in the chat maybe. Confirm. Yes, all right, Joshua Thomas just confirmed. Josh, all right, great. So everyone's aware that we have the, it'll be again in some type of an online exam, but it'll follow the format of exam 1. Okay, it's going to be a comprehensive exam. Obviously, yeah. So obviously, I can't do it's it's open notes. Just it's individual though, so please make sure please make sure that you know it's individual, and don't forget about the exam next Monday. Okay. All right. So if there are no questions, then let's get started with today's topic. Okay. So I'm going to share my screen here. So I'm going to.
Hello, Professor. Sorry. Have you taken?
Go ahead. Yes, please.
Did you take attendance or?
I'm not taking. Oh, who is it? Susanna?
Yes. Hi.
So I did say this before. So I understand that everyone has difficult situations right now, so you may not be able to be here at all times. You are not required, and I will not take attendance. And I will post the videos on YouTube, right? So I can't really force you, but I'm doing this for your own help. Okay, so I'm gonna do the lectures. I'm gonna try out the lectures like this, and basically to answer your question.
Okay, for the test, are we going to submit it through Blackboard? Is that how we're going to do it?
Yeah, so I just said that the exam, obviously, it'll have to be through Blackboard. It'll be, I'll have to adapt it a little bit, but it'll be the same format, basically, just online.
Okay, we'll just have the 2 hours like during.
Yeah, so exactly. So that's the one thing that it's not a take-home exam per se. I mean, I think that would be rather challenging if I gave you a take-home exam. You already have plenty of labs and projects. So instead, it's just going to be like the first exam, but online. So obviously, there's some things that I will have to adapt, essay type, coding type, and it'll last. I can give you the 2 hours. So for instance, your class is at 2, right?
Mm-hmm.
From 2 to 4, and then maybe 2 to, actually it can be probably 2 to 4 because all I have to do is schedule it in Blackboard. So yeah, it would be 2 to 4, and then maybe I'll have the other class, the other section also take it between 2 and 4. I'll ask them, but I don't know that, it doesn't matter for you guys. So it'll be from 2 to 4, yes.
Okay.
Anything else?
All right, good. Thank you.
Any other questions? Yeah.
How are you supposed to do the group project?
Who is this? Sorry.
John.
John. Oh yeah, John. Yeah, that's a good question. How are you supposed to do the group project? Do you mean, so there's 2 projects, right? One is one is actually very easy to do. You just have to do it. You have to research a topic in system administration, right? So that one you can do via email and online, and maybe you can use Zoom as well, or tools such as these. For the Hadoop one, so what I would say is do your best, help each other out. Someone would have to have the 3 VMs on their machine. I mean, that's obviously the way that it has to be. So someone or everyone. So the way that you might do it is everyone just has the 3 VMs. So, or even 2. I would even be okay with just 2 VMs at this point. And help each other to configure the architecture. Does that answer your question, John?
I guess. I mean.
Yeah. Yeah, I know.
It's harder because we can't really meet up.
I agree with you 100%. It's harder. So obviously, given this circumstance, I'll take that into consideration. At the end of the day, it's important to, this is supposed to be where you practice a lot of configuring a very difficult thing in Linux. It's supposed to be about admin. And so it's really everything that we've covered throughout the semester that you're putting together into this one thing. So what I would recommend is you can start setting up a Hadoop cluster of just one. And that's the easiest thing to do. So do at least, so this is my recommendation. I'm not saying that you don't have to do the cluster, but my recommendation is at least start and make sure you can do a cluster of one. Does that make sense?
Yeah, I think so.
Yeah, so a cluster of one would basically mean that you have a Hadoop cluster where one machine is, using the terminology of Hadoop, that one is the master and one is the same machine is both master and the slave. So it's basically the machine that is the manager and the machine that it manages. And
Okay.
after that, try to add one more. You know, it's a little bit more complex to have. So definitely, let's keep it at that. Just two nodes in the cluster at most is required, and then but do it. You know, you start with just one, and a lot of the configuration is very similar when you're doing the single node. So at least that will get you to understand it, and then maybe scale up to a 2-node cluster.
Okay.
Okay. Anything else? Any other questions, guys? Okay, so it seems there are no other questions. That's good. You can always ask me questions. As I said, on Wednesday, I will do this again. Keep in mind, we're still kind of doing lectures and labs. So on Wednesday, I will do basically the lab for this new topic. Okay. And of course, if anyone has a question, just ask, please. You know, like, you can stop me at any time, so that's okay too. All right, so let's try this out. Okay, so I assume there are no more questions. All right, so let's go ahead. So the great thing about, you know, when this, you know, if there's anything good about this, I would say, at least, is that we were almost done with like 60% of the semester. So, you know, if you think about it, file system analysis, I had a chance to cover that in class that Wednesday before spring break. And so I covered that topic, and then I posted the videos last week. So, you know, kind of did a little bit of a review in the videos of what I had said on Wednesday. So please work on those assignments. They're due, I believe, sometime this week. So make sure you turn them in. The next topic that I'm going to cover is one of the last main topics of the course, which is something called the Simple Network Management Protocol, SNMP. And this is a good service to talk about. It has existed for a long time. Historically, it's been very, very important. I should say that nowadays Windows has kind of disabled this on their servers because they actually want to sell this as a product. So it's not that it's not there anymore, but instead it's that they've decided to market SNMP as a product. So they want to commercialize it. And so obviously on the Linux side, Linux is, or Unix, I should say, is open source. And therefore, this is still a service that's available. No one's trying to commercialize it. These things evolve over time, but I think what's important about this is to understand the idea. Okay, so to understand the idea of what SNMP really is. Okay. All right, so what SNMP really is. So, right, SNMP. All right, so the Simple Network Management Protocol. I would say that this evolves over time, and companies will try to change it. But what's important for you guys to understand is as I said, the basic idea and the basic principles of this. So, in essence, SNMP, throughout this class, we have focused on, system performance analysis or looking up statistics about the your host machines, right? And you wrote some scripts and everything, and all of that is very useful. But as it turns out, there's actually a service built into all devices, right? Not just like Linux, but Windows, printers, Cisco routers and switches and firewalls. So all devices actually can have this protocol called Snmp. And the idea is that, by having this, you can have something called a NOC, right? You can have something called a NOC, which is a Networks Operations Center. So the way that, I like to describe this is you might imagine that you have a room, right? You have a room, and in that room you have basically a lot of monitors and screens and everything. It's like a dashboard. And that dashboard reports back to you information about your entire network, right? So it's a way of looking at a big picture. So that's why this topic is really important, because you can have lots of machines. You can have a host, and then you can have a server, and then you can have a printer, right? And then you can have a router, and whatever devices that you have in the network, all of these machines are going to send data back. They're going to send data back to one central computer, which could be like one central server, right? And that's going to be your NOC, or the NOC server, or it could be several servers. So the idea is that this protocol defines, so the protocol Snmp defines a lot of things about how this communication is established, about the information that is sent, and how it's sent, right? So we're going to explore a lot of this, and then so I'm going to do the lecture today, and then next week, or sorry, on Wednesday, you guys will work on the lab for this. And the lab for this is really nice because you basically, it's several components. First, you're going to establish Snmp service. So you're going to establish the Snmp service on your on all the individual machines. So you start up that service, and then you start up that service also on the admin machine, right? So on the admin machine, you're going to establish that service, and then once you have that, all of these machines automatically will report back to that server. And that's really great, because then you don't have to have 20 or 30 scripts that you're running. Instead, you have one single protocol whose purpose is to send data back to the server itself. All right, so that's what's very useful about it. And then on top of that, we are going to build a web app. So we're going to have a web app, and we don't have to write the code here. Instead, we have a web application that will read the data from the server, from the Snmp databases, if you will, and then present the data for you. So it's going to create a lot of very useful graphs. So it'll create very useful graphs, charts, and so on. And all of that is done automatically, right? But we have to consider how all of this works. All right, so today we're going to kind of get a big picture of what this is. We're going to get a big picture of what the lab will entail. This lab is a lot easier than, say, like the DNS lab or certainly the Hadoop lab. So this lab is, although it might sound like it's difficult, it's actually not very difficult. So my plan is on Wednesday, I will go over the lab document. So I have a lab document, obviously, and that has all the steps that you have to take. So you can you can take a look at that. And today I'm just going to go over kind of the theory. So how does it work, right? So how does Snmp work? Keep in mind, since we're covering this today, this will be on the next exam, at least this lecture. Maybe not the lab, because you're still will be working on it, but certainly the lecture aspect. So again, I remind you, you can ask questions at any time if something is not clear. All right. So you know, we want to define a few concepts, all right? So if you think about it, before we focus, you know, this course is about Unix and understanding Unix, but also about understanding system administration, right? Which basically means configuring Unix. So far we have looked at, basically we focus on the host, right? So we've done a few labs where we've integrated, you know, clusters for DNS, but mainly we focus on the host. This is the topic or the lab, if you will, that allows us to focus on the network as a whole, right? So the network as a whole. So obviously you don't, and I'm not going to ask you guys on the lab to include printers or routers and switches. We don't have access to that right now with the current situation, but you can use virtual machines, right? So you'll be able to use, you know, 2 or 3, even maybe you have a Windows VM, and you can prove to yourself that you can actually get Windows and Linux to both use SNMP to send information back to a centralized SNMP manager. All right, so the first thing we want to define is, so as I said, the idea is that the focus right now is, you know, well, basically on the network, right? So we're focusing now on managing the network effectively. So as it turns out, SNMP can both read and write. So what that means is that you can actually query information from every device in your network through this protocol, this idea, which I think is the best solution, honestly, instead of having independent companies creating their own applications. So this is, I think, a great solution to have at SNMP. So I am definitely for SNMP. So basically, the idea is that you want to manage the network and you want to collect information from the network. So SNMP can actually do both 2 things, read and write. And the idea there is that with a read, you query information from the network, right? And with a write, you actually send information to the different variables in the machine. So you could technically change information about the machines, but usually for SNMP purposes, you don't use this. So there are other protocols or other approaches, right, where you do send information, all the configurations from one machine to, you know, when you manage, you know, computers. But this is not necessary. You know, SNMP is not really, although it has the capability, it's usually by default disabled, right? And the focus is basically just on monitoring the network, right? So I want you to understand that. Very important, although, you know, and we'll talk about that really the focus is just to collect data from the nodes and view basically the health of the network. And this will become very obvious as you start, you know, that's why the labs are usually very important. Once you see the labs, it'll make sense what you're doing. So under network management, we have some basic tasks that can fall under this category. And so we will look at them here. So you have configuration management, you have fault management, and you have performance management, right? So, you know, configuration management, keep track of device settings and how they function, right? So this might be where you not only look at what the configurations are, but you can also set them remotely, right? Configuration management. Then there's fault management, dealing with problems and emergencies in the network. You know, something such as a server loses power or a router stops routing, etc. So assuming the device still has power, if there's a fault in the system, SNMP can send a message, can send basically an alert to the manager in the network, and the manager will then report that, right? So in your network operations center, you would see that happened. The device went down, for instance. All right, and then you have performance management, right? You know, and that basically means how smoothly is the network running? Can it handle the workload it currently has? So that's the idea, that what you're gonna end up having is you're gonna have little graphs, right? You might imagine you have graphs, and you see how the network is doing. And so that's what that translates into. So how smoothly is the network running? And so it'll become amazing, I think, to you guys to see that how easy we'll use a tool called Ph.D. and you can, it's a Unix open source tool. And so you'll see how easy it is to just report graphs or create graphs on just about anything. And so that's why it's, this is very useful. So I think, in my opinion, I would say SNMP is really good at performance management. It's also good at fault management, especially when it reports that a system is down. It's not so much for configuration management, I would say, except maybe you want to read information about the system, but you don't really want to send information. And the reason for that is basically security, right? So as you might imagine, you don't really want one machine that could control everything, and if it gets compromised, you have an issue. Now, SNMP is an internal network protocol, basically, so it's not really over the internet. So it does have that in terms of security, but as I said, write is discouraged, and it's mainly for reading. So it'll be very good for performance management. Are there any questions? Okay, so yeah, go ahead.
I was going to say I don't have any questions.
Oh, okay.
No.
All right. Thank you. All right. So that's network. The basic idea with network management. All right. So some functional areas of network management would be, so we can break this down further into a few additional areas. So functional management, for configuration management, the configuration, obviously keeping track of inventory. So that's useful. In the network operations center, you can keep track of the inventory of all your devices in the network. As I said, fault management, where it can be reactive or proactive, right? So, the idea with proactive with this approach is that the device can start sending messages back to you, right? It can start sending messages back to you before it actually goes down. Maybe, it's usually a sequence of events that happens, and so maybe you can catch it early and be proactive. As I said, one of the great benefits of this is performance management, where you look at the number of packets that have been dropped, timeouts, collisions, errors, right? So believe it or not, every device, let's just take a Linux server, and you'll see this in your lab when you do an Snmp walk, can have 4,000, 5,000 variables, right? And all of these variables store information, all kinds of information about that system, right? And so not all variables are in use by default, and we're not going to go into so much depth of creating, adding all the variables, but you'll be able to see how some of the variables do have data and they report it back. So security management, SNMP doesn't provide much here. It's not, so I should stress, it's not a security tool in any way. It's basically meant to be for, as I said, management and mainly monitoring. Accounting management, so cost management. So this can be very useful because, you'll keep track of, by looking at the graphs and utilization, you can kind of keep track of the cost of the device, asset management as well, right? So you can have statistics of equipment, right? And personnel and how everything is, you can correlate things, right? From the utilization and your graphs, basically. And this can be very helpful for planning management, right? So because now you can, although our focus will be just on looking at the data, this is not a data analysis course, we're not going to do like statistical things with the data. If you think about it, you'll see later on that you have these graphs about, utilization of RAM or memory or disk and things like that. So you can use that for analysis of trends, right? And by doing analysis of trends, that will help you to justify with management any network upgrades, because you can say, hey, we need to, buy more equipment, add more bandwidth, and here's the justification. Over the last 3 months, this has been, look at the graphs, this has been the utilization. So as you can see, it's a very useful tool for that. So usually I like to, think of it as very important for monitoring. Okay, so monitoring. right? So these are all the applications of it. All right, so we need to provide a formal definition of this idea of SNMP. Okay, this, you know, as I said, this has been a historical protocol that has evolved over time, but I think the essence of it remains, regardless of how they want to commercialize this product now. So SNMP is a tool or a protocol, really, and that's really what we're gonna. So there's a lot of detail into creating SNMP. And SNMP is made really for vendors to be able to create. You know, it's made in such a way that SNMP can be used for any vendor, is what I'm saying. So if, as you might imagine, if you're a new company, let's say that you're a new iPhone or Mac, and you create a new computer today, well, that computer needs to use SNMP, and therefore the protocol needs to allow for that company to incorporate their new product into the environment of SNMP. And so we will see later on that the protocol defines these things called MIBs, and that's not Men in Black, right? So that's these are databases of how information should be created, right? So how, you know, it's basically like data structures. How do you define data structures about your new hardware that will allow SNMP to query that data, right? And so that's really what we're going to look at. So what I'm trying to say is that it's a very big protocol, actually. It's a very big protocol made up of individual things, right? From very high level things to very low level things. But anyway, so let's define it. So SNMP is a tool or protocol that allows for remote and local management of items on the network, including servers, workstations, routers, switches, and all other managed devices, even legacy devices, because a legacy device could have like a bridge, right? So you could create a bridge between the legacy device and your protocol. And so that's really the idea. It's a very handy concept. So it, you know, like I said, it's for management, basically, for monitoring, you know, for all kinds of things. It's comprised of agents and managers, and that's really the idea. Imagine it's, you know, you've learned already that everything is a file in Unix. I'm sure you're aware that, you know, Cisco products like routers and switches and all of those, a printer, they're basically firmware of the company, but at the end of the day, you can always just think of them as Unix kernels, right? So think of it as a Unix kernel that a company took and extended it, obviously, to be a router, to be a firewall. But at the end of the day, they're very similar, right? So that's really a very important takeaway. And so all these agents and managers, they're really just, you know, you can think of them as firmware, but really Unix kernels, and then basically they have a little bit of software in them running a service that talks SNMP, right? So there's going to be SNMP will be associated with a port number, obviously, and then through that, that little piece of software in the printer will be able to talk to a piece of software in the SNMP manager, and the router, and the fire, and all of them will all have that software. Okay, so those pieces of software are divided into agents and managers. And I think I have a graph coming up. So agent is basically a process, what I said, a little piece of code, right? So process running on each managed node, collecting information about the device it is running on. So I think that's a very clear definition. Whereas the manager, again, another piece of code, right? A process running, usually they're probably, you know, like C type of code. So a process running on a management workstation that requests information about the devices in the network, okay? So that's basically the idea. So some of the advantages of something like SNMP, this concept, is that it's basically standardized. So the idea is that it was created literally so that it could run on all kinds of technologies, even Internet of Things, right? So the Internet of Things, let's think about the Internet of Things. So it's a very new set of hardware nowadays. And it is connected to the network, right? But even IoT devices could, in theory, have SNMP. And what's so great about it is if you're a company now that has a lot of IoT devices in your network, all of those devices through the network, through UDP, actually, IoT is UDP. So through UDP, they'll be able to send out packets, you know, just one little packet, so it doesn't consume that much bandwidth, right? So they send out packets back to the manager, and that way you can keep track in real time of your entire network. So I've always liked SNMP. I think it's such a really nice concept that allows you to monitor the entire network. Right, so the advantages of using SNMP is that it is standardized, right? It's universally supported, okay? It's extendable, and that means that, you know, you could define something, but you can always add to it, right? Portable from any device, right? Allows distributed management access. This is so great, right? So from one centralized, you can, you know, sit in your office having some coffee and basically in your network operations center, look at the entire health of your network, right? And it's a lightweight protocol, so it doesn't really cause that much strain on the network. So it's really hard to beat something like this, to be honest, right? So I think in the past, Windows took SNMP off and then they had to put it back because it's a useful idea. Are there any questions before I continue, guys? And you guys can hear me, correct?
Yes.
All right, thank you. All right, so let's continue. All right, so SNMP basically exposes management data, right? So that's the idea. You have variables on the managed systems, right? So what I'm trying to say here is that things are defined as variables. Okay, so things are defined just like you would think in a regular program. You would define a little variable and it stores some data, you know, a little buffer. So it's the same thing with SNMP. Okay, so you have a packet. Imagine you have a network packet, right? Packet. And then this packet in its payload will carry the information. In a variable about a machine. So something that has been queried. So, you know, the manager will query that particular information from a variable in a managed device, right? So SNMP exposes management data, so variables in the managed system, and describe the system configuration. So basically you can provide information about configuration or about the status of the machine. These variables, which are the main unit, can be queried and sometimes set. So remember that, so that basically translates into read and write. And if you wanted to, you could configure your SNMP protocol on your Unix system to write to the variables. However, as I said, really, for security reasons, that's not really, it's not recommended. All right, so these variables can be queried by managing applications, right? And that's what you're gonna have. So you're gonna have a manager, right? And the manager, basically, and then there's a host. So it sends a query, right? So it sends the query, and then basically the device sends the response, which is going to be just a simple UDP packet. Okay, so this is the manager, this is the agent. Okay? All right, so that's kind of the idea there. All right, so what are some, you know, a little overview here. So SNmp agents will basically show data of interest on the managed systems. Okay, so the variables will host information or hold information such as memory, the system name, number of running processes, what is the default route. So as you can see, a lot of information, right? You can have route information, right? Which is it's really a string made up of some information, various pieces of information. It could be the system name. So I think when we do the lab, so in the lab, your very first problem will be to query the name. Now, keep in mind, it's very easy. You'll create, you'll have a 1604 VM, and which is what we're currently using this semester. And then you will configure both the agent and the manager in that machine itself. So the machine then, it'll be configured for Snmp. Then you will act as the manager and do something called an Snmp walk. When you do the Snmp walk, it's a very simple command line command, basically, that will allow you to look at the values of all the variables in the device. Okay, so yeah, so that's the idea. And so you'll be, the very first thing that you will query is the system name, right? So maybe even you can put your name in a specific variable like system administrator, you'll be able to query that as well. All right, so, but really I should say, not just these 4 things, but in the thousands, right? So thousands of, if you can think of it, you can set it, right? So thousands of pieces of information can be extracted from a system, right? That's the beauty of Snmp, is that this is not fixed. Instead, this is extensible. Every company, Hewlett Packard and so on, they can, Dell, all the computers that manufacture products, Macintosh, certainly, they can define what their MIBs will be, what their databases will be of information, and what can be queried and what can't. Okay? So variables accessible via an Snmp are organized in hierarchies, right? And we will look at this hierarchy. Everything is going to look like, every variable will have an ID basically, which is going to look like 2, 3, 7, 5, and then maybe 36, and then 2, and so on. All right, so there's going to be a hierarchical architecture. So I should say that this topic will be made up of 2 labs. The first lab is just very much a sysadmin. There will be no real scripting of any kind. The second lab will involve a little bit more Python scripting, but by doing that Python scripting, we will be able to, get a better, keeps doing that. We will be able to get a better understanding on how this works. So this is the way that most information is organized in computers. Even Active Directory, for instance, follows a similar idea. So anyway, these variables, which are accessible via Snmp, are organized in hierarchies. These hierarchies and other metadata are described by something called the, as I said, the MIBs, where, excuse me, where MIB stands for Management Information Bases. Management Information Bases. And we will define this later, but for now you can think of this as a simple data structure. Simple data structure. And what that data, and it has even its own syntax and everything. And what that data structure does is that it allows you to have type and description of the variable. So you can have a type and description of the variable. Okay. So here we have an example. So Snmp's in its most basic form, as I said, remember I said it's a UDP type of protocol. So you don't really care if you lose data in the network. Basically you can query again. But the way it works is a packet is sent. So a packet is sent to a network device. Let's say a router or a printer, right? So you send a packet, and the packet is obviously is going to be an Snmp formed, properly formed packet, and it's going to have a query or a question called a get. So there's about 4 commands that Snmp is a very simple protocol, and so it has you know, a get command. So for example, one might ask, you know, what is the value of IF stands for interface. So what is the value of interface, MIB, and then you have interface out octets 1. All right, so for that one interface, the network, and this refers to the network interface, you would want to know how many out octets you have had, right? So you're measuring some kind of outgoing information. So that's what the MIB needs to define all of these variables, right? But you don't have to do it. They're already defined. So a machine or a computer, whenever it's created, you know, the manufacturer would have to create that MIB for those devices. Are there any questions, guys?
No.
All right, no questions, all right. Thank you for giving me that feedback. It's just because you know, I don't want to like talk for half an hour and then something broke or something. I lost my internet. All right, so anyway, so yeah, so SNMP has these commands like a get command, and you know, you have the, you know, you query some variable. There are, as I said, thousands of variables. When we do the second lab that we will do, I will actually give you a little bit of information on how to query specific variables. So we'll take a look at that in the second lab. You can, and basically in the first lab, you can assume you're just going to load everything, and then you're going to kind of select the variables that you have available there and extract the information. All right. Right, so you can see here that variable is in the group of interfaces, right? So you can see things are organized, and we'll see this later. Because it's a hierarchical tree, everything is organized kinda by the pieces of hardware in the machine. So for instance, any network device has an interface, right? Or two, right? And so that's an important concept. It means that basically, whenever you create MIBs, there's like a skeleton or default type of set of hardware that you have available, right? So they'll have processors, they'll have memory, they'll have interfaces. And so the hierarchical tree, you know, comes in like this. It'll have, you know, interface, memory, processor, and so on, right? And then these will be divided into other things as well. Okay, so that's basically what is meant by it has a hierarchical organization. Okay, so anyway, to complete this scenario, so you query the variable from the device, all right, and then the router replies with a packet containing the value. So it's very simple, right? You query the variable, and then the router replies using SNMP. It will reply with a packet, and it just contains the value, or it might be 0 if there's nothing in there as well. And there are variables for just about everything and every kind of technology in this type of a protocol. So as you can see, you know, this is very, very useful. So an overview of SNMP, so it defines mechanisms for remote management of network devices, so kind of a summary here. Remote management of network devices, any kind. It's fundamental principle, all device management done by simple variable value manipulation. So really, you know, nothing very complex, just sending the values. Because you really think about it, this kind of goes back to when we had our discussion of distributed computing and cluster computing, right? So if you remember, one of those principles is that you don't want to overload the network, right? So you have to build protocols that send as little information as possible. And so this is a great solution in the sense that you query what you want, and it is very basic information. And of course, so SNMP will have protocols for requesting, returning, notifying of changes of values, etc. So these are the commands that we will take a look at in a second. right? So here's a nice little graph or diagram, right? So of the Snmp components, right? So we can see, for instance, in this case, we have a network, right? And we have the management station, which is this one, Snmp, the management station, Snmp, all right? And then we have various agents. So you have this agent over here, this agent over here, this agent, and so on, right? So you can see one is a router, one is a bridge, one is a printer, one is a host, right? And all of these computers are going to return, because they have their Snmp protocols, right? So they're going to return data back to the manager. The manager will receive that data, store it in some kind of a database. We'll even do this in the second lab. We will actually write our own code, which will allow us to query the data ourselves, and Snmp data though, and we're going to store it in our own database. So instead of using the database that we're going to use for lab 1 and lab 2 of Snmp, we will actually be able to, I'll give you a lot of this code though, so don't worry, it's a bit complex code, so I'll provide the code, but basically you'll be able to store the data in your own database, and then at that point you can really just build your own application, because what's happening there is you get some kind of a GUI. And see, this is the thing. This is the reason why companies want to commercialize protocols like Snmp. I'm sure you can see right now that this is useful. So I'm sure this is obvious that being able to query information about all your systems is useful. All right. And so the question comes in that, companies want to market these GUIs because they're ultimately, web type of applications, right? So you have web type of applications to read the information from these databases. And then not only do you have the potential to have the data, but you can create graphs. And importantly, what a lot of companies want to sell you is reports, right? So they want to be able to create reports, very powerful reports that are very useful. And so that translates into dollars, right? So that's why, in the second lab, we're going to take, instead of just using some tool, we're actually going to try to build some of this ourselves. We're going to keep it pretty simple, but I think it should give you enough insight into how you could, build an application like this. Okay. All right. So I talked about the Snmp Walk. So this is an example of Snmp, right? So this will be your very first, I think it's the very first question or problem in your lab that you have to do this, right? So you have to do an Snmp Walk. If you notice, the way it works is it uses a very simple password. The password is called the public string. It's not encrypted or anything. Especially the protocol of Snmp that we're going to use is very light. There are versions, so you can see here, we're going to be using either, I think in the handout I put like version 2, but there are, I think, version 3 and on, as the product become available, they do provide these features. Like, someone might sell you one of these that, even though it's built on the idea of Snmp, it provides more. It provides more capacity, like cryptography, right? So you guys took 350 already, so you know that cryptography is, is pretty straightforward to implement. And so the idea is to protect the data, right? So protect the data of the network. Obviously, the problem with cryptography, especially when you're dealing with something like this, is that it does provide an additional burden on the network, right? And additionally, I should say, remember, Snmp is more of an internal network kind of a tool, although you could use it externally as well. If you use it externally, definitely you want to encrypt things internally for our purposes. Like if you're just monitoring all the computers in your house, for instance, you don't have to, encrypt it. It's not necessary. But anyway, but at least, so basically, so the version really relates, in some way to that, right? What are all the higher the version, more services are provided, more security, and so on. However, all the versions will have this idea of the public string. And the way to think about it is that is a password. All right, the third element, if you notice, that's just a machine. So that, you know, in my example, some university, Stevens, you know, colt45.cs.stevens.edu. But you can, you know, obviously this, when you do your lab, this can be an IP, so it'll be 192.168.1.7. It could also be local host, right? Oops. Local host. And that's when you're doing, the current computer, right? So remember, you will do your lab first just on one, I'll explain this on Wednesday, but you will do your lab just on one machine, and then you will do your lab with multiple machines, right? And I do encourage you, if you have a Windows machine, doesn't matter what version it is, you can even try it with a Windows machine. So anyway, when you do a Snmp walk, what will happen is the following. With an Snmp walk, you will get, you will run it, right? So you click enter here, and then you will get all of this output, right? So you will get all of this output, and that just basically provides, if you notice, these are all the variables. You can see Snmp version 2, MIB, system description, right? And then you're gonna get, you know, something like HP, Ethernet, multi-environment, so on, and all of this, right? So whatever's in that description. Notice how large the amount of information is that is contained in that variable. So that kind of should give you an intuition that not all variables are created equal, right? So the protocol needs to be able to handle the fact that some variables could be strings, very long strings, some are integers, right? Numbers and so on. If you look at the next variable, Snmp Mib System Object Id, right? And then, you know, OID, and you can see here you have a specific type of an ID. Then you have system uptime. Remember that uptime that is always, that we used at the very beginning of the semester. You know, you can, now you can query the uptime in a different way, right? So, you know, you were querying it through the Linux command line. Then we learned you could query it through scripts remotely. Now you're learning that you can query system uptime and so on through Snmp remotely, okay? And so obviously when you, the Snmp walk is, you know, the kind of thing that directly you don't want to use it, you could, right? So if you think about it, let's say that you want to pick an MIB here. You want to find, I'm going to do a little, I'm going to try a question, see how that works on this. But let's imagine that you want to find that system uptime, that information, right? And you run an Snmp walk. So you run an Snmp walk, right? And you know that an Snmp walk will give you this output, right? So then, how could you just on the command line get this line? Can anyone out there want to try that question? What are some ideas? You understand my question? You run this Snmp walk and you get this output, right? And then you want to focus in on that one. So how could you maybe modify this command or add to this command to be able to do that? Anyone? Are you guys still there?
Yeah.
Yeah.
Oh, some people are typing things. Is that how you're? Okay, let me see. I don't chat. Okay. All right. Well,
Could you just use grep?
Yeah, go ahead. Yeah, please. I'd rather, because help me by talking, please. Yes.
Couldn't you use grep and then just like grep sys uptime?
Exactly. Good job. That's Anthony, right? Anthony?
Yep.
Yeah, exactly. That's where I exactly, right? So you can use right, you can use exactly, right? We learned that you can we learned that you can pipe, right? And then just redirect this information and just use grep, right? So very good. Exactly. So you can see you could, I mean, in theory with Snmp Walk, you could actually query this information and get some details about this, right? But obviously this Snmp Walk is just for manually through the command line. It's a way of checking that it works. So usually the way that, the way that you'll be using Snmp Walk in your lab is that you're gonna run Snmp Walk. If you don't get any data, it'll mean what? That you probably misconfigured something. Once everything is configured correctly, then you'll do an Snmp Walk and it'll just give you lots of data. If you wanted to analyze this data on the command line, you could use grep, obviously, but otherwise, what's gonna happen is the protocol itself will allow you to query things through the protocol. And then once you have those things, you can save them in databases and then display them on your GUI interface. So yes, great. Thank you. All right, so let's see. So that's an example of Snmp Walk. So as I think I've said, Snmp items are called nodes. So items in an Snmp network are called nodes. There are different types of nodes. So we talked about managed nodes, management nodes, right? So typically runs an agent process that services requests from a management node. And then the management node is typically a workstation running some monitoring software. Now, another thing that you might have is nodes that are not manageable by Snmp. So these are the legacy things, right? So remember we talked about that. So legacy things. Legacy things. So a node may not support Snmp, but may be manageable by Snmp through a proxy agent running on another machine, right? So that's, a possibility. And of course, nodes can be both managed nodes and management nodes at the same time. And that's really the manager machine. That's something that you will do in your lab. Right, so here's another example, another graph of what we're talking about here. So you can see you have a manager device, right, connected to the network, right? And then all of these devices in the network are agents. So that's an agent, that's an agent, that's an agent. And then you can have another manager. There's no reason why you can't have another manager in the network. And then just keep in mind that whenever you, let's say this one is querying that agent, you're going to basically be querying, these variables, right? So you'll be querying those agent variables. So that information, you're going to query it, and then it's going to return back to the manager. Remember that the information is not changed, it is just queried, okay? All right. All right, so we talked about this, proxies and gateways. All right, so 4 basic operations. So now that we're here, this is important. All right, so this is, these are the 4 basic operations that we'll be focusing on for this topic, right, for the lecture in the lab. So basically there are gets, get next, set, and traps, right? So these are the 4 main things that we want to understand. So we're going to define each one. So for instance, we have the get, and the get is the basic command. Does all the, all the retrieving the value of an MIB variable stored on the agent machine. So this can be an integer, string, address of another MIB variable, and so on. All right, so it can be lots of different data types. Get next is a way, it's basically get next is basically a way that it's like get with a loop. So it retrieves the next value of the next lexical MIB. Okay, so the way that I would describe it is it's get in a loop. So it retrieves the next value of the next lexical MIB variable. So it's a way that we're not going to use get next that much, but it's basically so that you can query all the variables in an MIB. Okay, and then so the important ones are really this one, and this one. All right, and we will focus our attention on them. Now the set, you should know about it, but we will not be using it. I leave it to you guys. It's not, what I should say is, it's not part of the lab. It's not a requirement in the lab that you use set. However, you can, if just for your own, maybe you want to change the name of the computer or something like that, you can try it, all right? So you'll need to do some configuration, obviously, because you need to define some permissions, all right? And that's something that, on Wednesday, I will define in the lab itself. All right, so, but the set basically, its definition is that it can change the value of an MIB variable. So it could, in theory, change that, that value of an MIB variable, okay? All right, the trap, now the trap is very interesting. It's a very interesting technique. So the definition of it is that it's an unsolicited notification sent by an agent to a management application. It's typically a notification of something unexpected like an error. So think of this scenario, right? So with a get, you just have the manager, and the manager sends a packet to the router, what is this variable? The router replies. With a set, same thing, the manager wants to change some variable and an agent sends the command, done. With the trap, what happens is different. You have basically, imagine you have the manager just sitting there, and then you have maybe a router or a switch. And the router or the switch, let's imagine it has two power supplies, right? And they're both connected somehow. But then something happens, somebody unplugs the cable, maybe something like that, and that power supply is off, but this other one obviously is still on. And so what happens is, at that point, the router over here notices that, hey, one of my power supplies is off, right? Is off or disconnected. And therefore, it sends a packet to the network, to the manager, and that is called a trap, because it sends it. So notice the keyword there. It's unsolicited, right? So the packet was unsolicited, and it sends back to the manager to kind of report. So it's relevant. That distinguishes the difference is important. Distinguishing between these two things is important because they will use different port numbers. So the protocol will have different port numbers for the get or the trap. Okay, but that's in essence the basic idea. Does that make sense, guys? Are there any questions so far?
No, not yet.
No. Okay. Thank you. All right. Guys, if you have questions, I'd rather you ask them because it's a little bit difficult for me to check that chat. Okay, so let's keep going. All right, so I just talked about the traps, but let's go over this definition. So traps are unrequested event reports, right? So I just said that. So they're unrequested event reports that are sent to a management system by an SNMP agent process. When a trappable event occurs, a trap message is generated by the agent and is sent to a trap destination, right? So, and which is has to be a configured network address, the manager. So when you configure on the agent, you're gonna have to specify, okay, you know, who do I send this to, right? So there's gotta be a manager, because you will not receive an original IP that you, an original packet that you're responding to. Okay, many agents can be configured to signal a trap, right? Like, I just gave this example, like a network cable fault, a failing NIC card or hard drive, a general protection fault, I mean, etc. So it's, you know, there's no limits here, power supply failure, and so on. So there could be a lot of possibilities here. You can also throttle traps, so you can limit the number of traps sent per second from the agent, right? So, you know, you could, I mean, think about it. Computers, they could report lots of things, right? So, hey, there's too much utilization of the network. Hey, the RAM memory is exceeding this, and so on. So you can see, actually, you know, although this is not for security, if you thought of this as SNMP could feed into an anomaly detection, or and for those of you in 454, we'll talk about this in the coming weeks, you know, an anomaly detection system or an IDS system could use this data, right, to monitor the network, not just for the health of the network per se, but now for security reasons, right? So because these traps can provide information, hey, you know what, at 2 a.m., you know, every day there's a high peak, you know, in utilization of the bandwidth, and that never happened on this host, something like that, right? So that information is sent back and then could be used as a type of an anomaly detection as well. But anyway, so the point here is that traps, you could potentially get a lot of information back, and so they can be throttled in case that is a little bit excessive. And they also, just like, again, you know, this idea of traps is very similar to alerts and intrusion detection systems in the sense that not only do they produce a lot of information, but they can also have priorities. So traps have a priority associated with them. So it can be like critical, major, minor, warning. And this allows you basically to rank things. And so a system administrator can focus on the things, you know, for instance, critical, major, and so on. All right. So imagine, for instance, here on the concept of traps, traps are received by a management application, and then you might imagine that the management application, and this again goes back to the idea of these GUIs that people are selling you for a lot of money, right? So, you know, it actually, or if you're a company and you want to monitor your network, wouldn't it be nice if, like, one of the power supplies of the main server goes down, if you could get an email, right, saying that the supply is going down. And so, you know, again, that's why I keep saying that this SNMP is a type of protocol that companies try to commercialize quite a bit. And so Unix has it as an open source thing, but other companies might hide this a little bit. So think about the traps, for instance, here, this scenario. You know, traps are received by a management application. And then that application, your GUI, depending on who your vendor is or whether you wrote the code, as we will see in lab 2, you literally could build this GUI, right? And there's no limit to everything that you can do. So another thing that it could support would be that it can handle traps in a few ways. For instance, you know, you can pull the agent and send the trap for more info. Okay, you know, you can start doing more of a diagnostic of the device. So that's a possibility. So it basically, the alert just triggers the diagnostics from the manager, and then the manager now starts getting all the information, right? So that's actually very useful. So you diagnostics of the event. and the status of the rest of the machine. Maybe machines around that area. Is it a problem localized to that area? So that's important. You can also log the reception. So you can log the reception of the trap. You create that log, and then you use the information for something else later on. Or obviously you can completely ignore the trap. So if it's not important, and then management applications, depending on what you have, can be set up to send an email or a voice, text, of everything. So you can see here, for instance, your server just blue screen, 346, have a nice day, right? Or something like that. So the idea is that, you allow a lot of, give a lot of power to the system administrator. So anyway, so hopefully this is clear. This is, the advantages or the uses of this idea of a simple protocol to manage the network. Okay. Are there any questions before I move? So now I'm going to move. So at this point, I've completed kind of the overview of the protocol, and now I'm going to move more into the details of how Snmp and how it's built, basically. So we're going to talk a little bit about how the protocol is made up of individual elements. So before I start this section, are there any questions?
Nope.
No questions. Just poor Alicia. She has to speak for everyone. All right. I mean, I will say though, if you guys have any questions, don't be shy or anything. Go ahead. We gotta adapt, right? So this is only my second time using this Zoom thing, so don't worry. Anyway, so now we're gonna move on to this second phase, as I said, and this part is important in the sense that it'll give you a little bit more insight of how things work, but I'm not gonna ask you to build any of this like in this way, right? So later on we'll code a little bit, and I'll stress the parts that are important, and then some parts will not be so important. Okay, as we're not gonna go into so much depth of this topic. I mean, this topic can be pretty detailed. All right, so to do management tasks, Snmp uses other protocols, basically. All right, so in essence, I've talked about MIBs already, right? So I talked about MIBs. So Snmp can use MIBs, but it also uses something else called SMI. So there's going to be a lot of little things that have these acronyms. And the best way to describe this is that they associate basically to a computer language. So whenever you would think of, like, if you learn C, C++, you learn the syntax and you learn how the data structures need to be defined, and all of those things, right? So that's the similar concept. So that's what we are. At the end of the day, what we're doing here in Unix is really defining a type of a language. And we just have to speak that language, which is the language that is used for the protocol. All right, so Snmp, architecture and model. So to understand this, Snmp can be divided into these models, or these 4 models, right? And what these models are is they're basically just different ways. I would just say this is just different ways. So these are just different ways of looking at Snmp itself, or network management protocols in general, right? Different ways. So you can look at it from the organization model, right? And I'll provide definitions of all of these, but you can look at it from the organizational point of view, from the information point of view, from the communication, how packets are sent and so on, and from the functional model, which is you know, what do they actually do, right? So certainly, definitely something well worth having, but, you know, because of the complexity of it, this is a protocol. It's funny, historically speaking, it started out as, you know, let's put together some ideas. This is good enough. Let's run with this, and then we're gonna make it really good. Well, years passed and they changed nothing, and then came the second revision, and it basically the approach has been constant, right? So it hasn't fundamentally changed, except, as I said, they added things like security, and really what really happens is at the very top level, the GUIs get modified. All right, but these are 4 different ways, as I said, of looking at this protocol, from organizational, informational, communication, and functional. All right, so now here we have a little bit more information. So the organizational model just deals with the relationship between network elements, such as the agents and the managers, right? So it's the hierarchical architecture, not of the data itself, but just of this idea that you have managers and agents, right? The informational model relates, as you might have figured out already, it deals with the data itself. So what I would say is the variables, right? So this deals with the Snmp variables. And this includes the MIB, of course, the MIB, which is the definition of the variables. And then to define those variables, you use things like something called SMI, the structure of management information. So as I said, it's like the data structures that you would use to define these MIBs, and then something called ASN1 syntax. Okay, and those are, as I said, less important things for us to worry about. But let's just think of the informational model as the thing that governs the variables, defining the variables, and then the syntax and everything necessary to define those variables themselves. And then we have the communication model, all right? And the communication model deals with, you know, as you might imagine, the packets. So think of it as the network, you know, or the packets maybe, that might be the key word to think about. So it deals with, you know, how do you transfer things, all right? So over TCP/IP or UDP, right? So, you know, that kind of example. The communication is addressed by messages, right? We learn about those commands. And then it talks about little things like the security framework, which basically its simplest security is this idea called community-based, and remember, it's the community string. It's the community string, right? Which is a password. Usually by default is the word public. So you probably don't want to leave that in there. All right. So anyway, so that's the, you know, that's the different models that we have available. And they're basically different points of view of the protocol itself, or these types of protocols. So another way, you know, when you think about the organizational model, as I said, we talked about agents and managers, right? And so basically you can create other organizational structures. So for instance, you have a one manager structure, you have that, right? A manager and then one, and then Snmp agents below, or multiple managers, right? And then, you know, that just means that you have multiple managers. So quite straightforward. Another organizational model that I've talked about already, these proxy ones, whenever you have a legacy system. So for instance, this is a non-SNMP managed object, so you just have a legacy, legacy, you know, or even IoT, it could be IoT, right? And maybe these IoT devices don't yet have that protocol because they're so limited. And so, but still you can query that data from another machine, you know, like a server, and then that machine converts it into a more SNMP standard, just so that you can have one standard across your network. So So this is possible, right? And, you know, creativity, innovation is happening all the time. And so, you know, even if you decide not to use SNMP, you could define your own protocol and take this type of an approach, a 3-tier organizational model where you have proxy servers to, you know, at the end of the day, you just have to follow the principles of not sending too much information, but you can collect all your data. All right. Notice that some of you from the other section are joining, and that's okay. And actually, since some of you may be here later, we might just combine both sections for these sessions. I don't know, but I'll need to talk to you guys about it. Austin, did you hear me? You can talk. All right, I don't know. Hopefully you hear me. Can you guys still hear me? Alicia, are you still there?
Yeah.
Yeah, I'm still here.
Okay, great, thank you. All right, so anyway, so I should ask, so at this point, are there any questions? Is this making sense, this idea? Guys, questions, anyone? You guys keep chatting there. Don't know. I click on chat. Oh, there we go. So let's see what the chat is saying. No questions, no, yes, thinking. All right. Oh, do we need to make, so actually let me see. There's some questions in this chat. Let's see. Yes, I can hear you fine. I can hear you. Do we need to make up a problem and fix it in? Yes, so in Hadoop, remember, there's two things. So remember, I talked about this at the beginning of the class about Hadoop, right? For those of you coming in a little late, remember I said, you don't have to have a cluster of 3, you can have a cluster of 2. My suggestion for everyone, because I had the question that how can you guys work in a group since, you know, you're doing social distancing. So definitely everyone should do the single node, okay? When you do a single node, obviously that's not, you know, the title of this is cluster computing, so it would be nice if you have 2 machines, but at least you need to have 1 machine acting both as the manager and the agent in the master and slave, sorry, in Hadoop lingo. And so that way the manager can run a job on the agents, right? So make sure that you do have at least a single node. And then once you have, which is a lot easier, I think. And then once you have that, at least try to add 1 second, and then you'll have a cluster. And so we meet that objective of you creating a cluster, okay? But yes, to answer Diana's question, once you configure it, you still want to run a job, but you can run the simple job that I gave you guys on counting. Now, the only thing is that lab, we did everything. I hope it's clear that you understand that we did everything in the terminal itself instead of doing it in Hadoop. So if you run that lab as we did it there, you're not using Hadoop. So to use Hadoop, you have to, it'll look something like this. You will have to, you know, like always run a command called Hadoop that takes different parameters. And then when you do this, the parameters are like the scripts themselves. So it could be that, it could be map, reduce, and so on, right? But you are the scripts, I mean the py, right? But I want you to understand that for you to use Hadoop, actually, your commands have to be run with Hadoop. If you just did what we did in the class where we started like cat and so on, you're just using the Linux machine. So this is an important thing. Once you configure the Hadoop, please do run a job, and you can just run that counting example that we did in the class. All right, let's see if there's any other questions.
So some people have questions like, since the school campus labs are closed and a lot of people don't have the hardware to run VMs, what are they supposed to do?
Okay, so that's a very good question. Yes. Okay. All right. So let's do this, guys. It's 3:30. Anyway, I'm recording this video, and I just want to. Can I do something? Can I close this, exit, save the video, and then I'll come back and then I'll answer any questions that you might have? Is that okay,
Yeah, sounds good.
John?
Yeah, that's, I guess, yeah, that's fine.
Yeah, it's just that I don't want to record all these questions and or unless you want, are you okay with, what would you rather do, John? I put it to you.
I mean, for people that aren't here and have similar questions, it's probably
Okay, all
best for
right,
they
so
hear
leave it.
it.
And so you don't mind that I post you on that's fine then. All right, so your question was, some people don't have like the enough RAM in their laptops to be able to run VMs, correct?
Yeah.
Yes, okay.
In my case, like I could run them, but they corrupt if I use them a second time.
They corrupt if you use them a second time. So you
Yeah.
want to have access to the desktops, correct? In the school.
Yeah, but the schools are closed now due to the,
Yes.
yeah.
Exactly. No, I 100% understand you. Okay, so these are the instructions that I've been given by my department head. He said that information services had figured out a way to grant you guys access to those desktops remotely. That is my, or some, maybe not those specific desktops, but desktops. So I could possibly, I mean, not that I could possibly, if you send me emails, anyone that's listening to this video in the course that has an issue like this, where they would want to have access remotely, like I imagine from your laptop, your remote desktop onto a Windows environment, and then can run your VMs. As I said, if that's what, if you have that request, send me an email. And what I can do is forward this to Professor Jang, and I believe Information Services then would give you instructions on how to do that. Do you think that would help you? Or anyone in that situation? John?
I mean, you won't know till you try it.
No, right.
So, I don't know.
That's this exactly at this point. So you obviously there's no way we're until April 30th. Everyone's on lockdown, correct? That's my understanding. So
From what I heard, yeah.
yeah, you're not gonna get into, the school is closed anyway. There's nobody there, so you're not gonna get access physically to those machines. So that's just fact. I've been given this option. I understand this is what they would do. I honestly don't know. I think I mean, what I would understand is you're going to use remote desktop, and remote desktop would get you into a Windows system, and then it's like you're there with remote desktop.
So what if that doesn't work?
Okay. All right. So I see where so that's, but I'm telling you right now, that's the alternative that I received an email, and that seems to be one option. If you don't, how can you, so you can't do all the labs, or for any students that have this issue, they can't do all the labs, or they can't do some labs?
I would guess any lab that involves VMs. Because like I said, for me,
If it's one VM, can you do it with just one VM?
well, here's my problem personally,
sir.
is when I run my VM, I'm able to do the assignments, but if I shut it down and try to access it again, it's all corrupt and I have to start all over.
Yeah.
That's my personal problem. Some people probably just don't have access to VMs because they can't run the hardware on their computers.
They can't run, or rather you're saying the hardware doesn't support the software, right?
From what my understanding is from a chat, so.
Yeah. Okay. So that the issue is that the hardware is not supporting. Yeah. Okay.
What about for people whose internet doesn't like? I'm at my house right now, but next
Yes.
week I'm going to be in Kentucky. And they have dial-up. I won't be able
No,
to.
right. This is the reason why I'm recording all videos. So I understand that you guys can't do, not everyone can do this. So I try to do this to be able to, answer questions. I will post all videos
Oh, I'm
on YouTube for sure.
I'm not talking about joining the sessions and stuff. I'm talking about theoretically remoting into the school stuff.
Oh, okay. Yeah, right. So you're going back, you said, to your home away, and then you could watch the videos. You just can't.
Yeah, if the videos load for like an hour or two, I can. But I doubt being able to remote into anything using like it's AOL dial-up from like 2000.
Right, right. So if could you take a VM, like maybe download a VM now on your computer, home computer maybe, and take it to your home in Kentucky, and then look at the videos, and then just solve it without internet access, at least whatever you can, and then just upload the report on Blackboard? Is that
Yeah, that's doable. But
okay?
I'm more so asking about the semester project.
Okay, so your concern is, okay, I think I understand. So you can do some of you could do some of the labs because you can, as long as they don't need internet, you can do them physically in your computer, and you would just need internet access to load on Blackboard and to watch the videos, correct? That's kind of, so the problem is the semester project because of the amount of memory. So if you just do Hadoop with one node,
If you're okay with that, I also
I'm
don't.
okay with it. I'm 100% okay with it.
What about my two other partners? How would I give them my work?
Do it individually. I mean, if you feel that you can't send a VM over the network, right? That's what you're telling me. Then create a group of one. So okay, let's do this. For those of you that can only, unfortunately, these are incredible circumstances, right? So for those of you that have these issues, could you do groups of one and just do a Hadoop cluster of one node and submit the report?
Can give it a shot.
Give it a shot. That at least sounds like it's possible.
Yeah, but I don't. I can't afford to retake this class, so I'll give it a shot, but I don't want to get like a fail if I can't get it to work.
No. I mean, as I said, these are extraordinary times. So at the end of the day, we've done 60% of the coursework. So if you think about it, if you got an A in everything already, right, you're around that 60 anyway. So what's important is, keep practicing Unix. That's the way that we're going to take this. Keep practicing Unix. I will still do my lectures and labs as if everything was normal. But obviously, when you submit your work, I will take these extraordinary circumstances under consideration, right? And it's really just practice the concepts, right? So if you can do a single node SNMP, oh, sorry, not SNMP, Hadoop, right? You can, and then SNMP would require, well, actually, you could even with SNMP, it can be both the manager and the agent. So you can actually query just the local host. So see, you can also do that one on just one machine. Does that make sense?
Yes.
Okay. So this was SAC, correct?
Yes.
SAC. So, all right. So do you have any further questions? Do you think this works for you?
I think so.
Okay. John?
I guess, what about people that just don't have access to anything to do it?
With what?
Like, I don't know, there's some people that don't really have computers and stuff like that. Well, obviously
Yeah.
I'm not one, but just for those kind of people.
Yeah. So can those people individually email me, and I will deal with that situation with them individually? As yeah, so I mean, I honestly can't do anything about it, so I have to pass that over to my department chair. But you know, hopefully that, you know, we'll find a solution. But just for those people that have that issue, maybe they can contact me via email. I did hear that the library, you can check out computers. So maybe some people could check out computers. I don't know if they're MacBooks or what they are, but I believe if you contact, so here, this is my understanding, and I may be wrong. If you contact the school's library and request a laptop, information services may provide a laptop for them to then give you, and then you can check that out, check that out until May, and then possibly then, if they do this other thing of remoting, maybe you could remote desktop from the machine into the school's computers. Guys, so John, does that?
Yeah, I mean, that sounds plausible for them, I guess.
Okay, yeah. So as I said, if you're in a situation where you definitely don't have hardware to try the solutions, please email me. That's the best thing I can say is please email me, and I will see what we can do through our department. Any other questions, guys?
Nope.
So like a side note real quick.
No,
so
go ahead, please. Go ahead.
For like more recent homework assignments, just because of all the stuff going on, are you just going to leave them open and then?
Yes, I can do that. I mean, that's certainly a possibility. Look, like I said, these are extraordinary times. I am trying to keep things the way they would have gone, obviously, but yes, I mean, I can definitely leave the assignments open. If you have questions, you know, ask. Yes, so yes.
Okay, just want to check.
Yeah, no, definitely. I can leave them open. So until, I mean, try to do them obviously. You know, try to do the ones that you think are easiest, right? You know, a scripting lab is worth the same as a very complex lab. And they're worth the same amount of points, and one might be a lot easier than the other, right? So, you know, do that. I mean, you know, with your time. I know you guys have issues with so many issues right now, so obviously. Yes. Anyone else, guys? All right, so it's, yeah, go ahead. Yeah.
Never mind. You answered it pretty much. It's not a big deal.
Okay. All right. So, well, if you have any other questions, you can email me. And, you know, we'll do this. So at any time, just ask questions. Obviously, you know, as I said, these are extraordinary times, so they require some accommodation, of course. If you have specific issues, please, that you didn't want to ask me over this, please just email me. If you have hardware issues, please email me. For those of you that want to use the remote access, email me as well about that, and I will forward that information. I think the Professor Zhang, he had asked for the list. And then for those of you that can only do the labs with one VM, then just do it with one VM. Okay, no need to have, if you have limits in memory. And yeah, and so we're gonna continue to, so I guess I'll stop here for today as far as the SNMP topic. I will, on Wednesday, I will do the lab description, and then next Monday, I remind you, is the exam that will be on Blackboard, and then we'll continue with these slides as time, as when we have another session again. And for those of you that, you know, are having issues with connecting to these live, I mean, I'm also recording videos, so I will post them on YouTube, and you can check them there through the calendar. Okay? All right, guys, so I'm gonna sign off because I need to have some time to create the video takes actually some time to generate. And then I have another class at 4 o'clock. So any final questions?
Nope.
No.
All right, great. Thank you. So I wish you the best, right? So hope everyone is doing well. I know it's difficult. And then I'll see you guys on Wednesday, and please email me if you have any further issues. Thank you.
Okay. Bye.